The preparations of haloalkanes and haloarenes as a part of revision series for board examination of class 12. Preparations of haloalkanes and haloarenes, RX and ARX. RX is haloalkanes, ARX is haloarenes. So there are different methods. The first one is from alcohols. From alcohols. Reaction of alcohols with halogen acids. Halogen acids means HX. X may be either chlorine, bromine or iodine. So here ROH plus HCl in the presence of zinc chloride. HCl in the presence of zinc chloride, we get RCl. So here, this is, let us take some examples. CH3CH2OH plus HCl. So zinc chloride, here OH and hydrogen is removed as water is removed, therefore we get CH3CH2Cl. Right. Now this is a primary alcohol, therefore it is a primary haloalkane. Suppose if we take a secondary alcohol, that is CH3CHOH CH3 plus HCl, here we get zinc chloride and minus H2O, therefore we get CH3CH2, this is CHCl CH3. This is a secondary haloalkane. So primary alkanes and secondary haloalkanes, what happens? Primary alcohols and secondary alcohols, we get primary haloalkanes and secondary haloalkanes. Then if we use tertiary alcohol, this is CH3OH plus simply hydrogen chloride, concentrated hydrochloric acid. Here zinc chloride is not necessary. Therefore what do we get? This is CH3CH3Cl. Now what is the purpose of zinc chloride here? The purpose of zinc chloride is, see here water is formed. Strictly speaking, this reaction is a reversible reaction. Alcohol plus hydrochloric acid is a reversible reaction. So whatever the water formed here, it takes part in the reaction once again. Therefore, backward reaction takes place. As backward reaction takes place, the haloalkane yield is not up to the mark. Therefore, zinc chloride being a deliquescent substance. Deliquescent substance is that which absorbs the moisture from the reaction. As moisture means here water content. Whatever the water content formed during this reaction, it is taken by zinc chloride. Therefore, the reaction goes only in one direction. Therefore, reaction comes to an end. That is, so the purpose of zinc chloride is to absorb the water formed during the reaction. See here, this tertiary alcohol is highly reactive. Therefore, zinc chloride is necessary to use in the preparation of tertiary alkyl halides. So this is the preparation of haloalkanes from alcohols. Now let us see the preparation of bromoalkanes. This is CH3CH2 OH plus in the presence of potassium bromide or sodium bromide, potassium bromide or sodium bromide in the presence of concentrated sulfuric acid, concentrated sulfuric acid. So when this potassium bromide reacts with the concentrated sulfuric acid or sodium bromide reacts with the concentrated sulfuric acid, what do we get? This is KBr plus H2SO4, we get KHSO4 plus HI. So this HI reacts with this alcohol, therefore we get here, see this is KBr, this is HBr. So CH3, CH2Br, CH3, CH2Br, right? Now this is bromoalkanes. This is bromoalkanes. Bromoalkanes. How do we get hydroalkanes? CH3 CH2OH in the presence of KBr plus H3PO4. We use phosphoric acid. Phosphoric acid. So what is the reaction with the KBr and phosphoric acid? This is a Ki plus H3PO4, H3PO4, we get KH2PO4, potassium dihydrogen phosphate plus hydrogen iodide. Hydrogen iodide. So this hydrogen iodide reacts with this alcohol, therefore we get CH3CH2I. CH3CH2I. So this is the preparation of hydroalkanes. Why can't we use concentrated sulfuric acid here in the preparation of potassium iodide? So here, if we use potassium iodide plus sulfuric acid, what do we get here? KH2PO4, potassium dihydrogen phosphate plus hydrogen iodide is formed. So we are getting hydrogen iodide. But so formed hydrogen iodide, when we use the concentrated sulfuric acid, this in the presence of this H2SO4, what happens? We get iodine. That means hydrogen iodide is oxidized to iodine. As hydrogen iodide is oxidized to iodine, the reaction does not take place. Therefore, with using concentrated sulfuric acid, the preparation of hydroalkane is not possible. Now, here the reactivity of this reaction means preparation of haloalkanes by reacting alcohols with halogen acids. Reactivity of this reaction towards halogen acids is HI is greater than, that means when we use hydrogen iodide, the reaction goes faster. HI is greater than, HBr is greater than HCl. Why it is so? The bond dissociation energy, BDE, bond dissociation energy of HI is least. As BDE is least, reaction goes faster. Therefore, it follows HI is greater than, HBr is greater than HCl. Similarly, the reactivity of this reaction towards alcohols, tertiary alcohol undergoes reaction faster. Tertiary is greater than, secondary is greater than primary. So this is the reactivity of alcohols with halogen acids. So preparation of haloalkanes by reacting alcohols with phosphorus halides using phosphorus halides. Phosphorus halides means maybe PCl3, PBr3, PI3, right? Now, so CH3 ethyl alcohol OH plus PCl3 phosphorus trichloride. When alcohol reacts with phosphorus trichloride, we get CH3 CH2 Cl plus H3PO3. Therefore, here 3 molecules here, 3 molecules here. This is phosphorus acid. Phosphorus acid. Similarly, this in reaction with PCl5, when ethyl alcohol reacts with phosphorus pentachloride, we get CH3CH2Cl plus POCl3 plus HCl. This is a phosphorus chloride, phosphorus oxychloride. So this is a reaction with phosphorus chlorides. Suppose, how do we get the reaction with the phosphorus bromide and phosphorus iodide? CH3 CH2 OH in the presence of red phosphorus plus Br2, So this is red phosphorus. What is the atomicity of phosphorus? 4. Phosphorus has P4 molecules. P4 plus Br2, we get PBr3. So this PBr3 reacts with alcohol. Therefore, we get CH3CH2Br. So this is PBr3. So however we get the reaction here in the same manner. Therefore, this is 3. This is 3. So what do we get here? H3PO3. So we get the phosphorus bromide. In the same manner, CH3 CH2OH in the presence of red phosphorus plus iodine. Red phosphorus plus iodine gives PI3, phosphorus triiodide. So what do we get here? CH3 CH2I plus H3PO3. 3 molecules. So using phosphorus halides, what happens? We get haloalkanes by reacting the phosphorus halides with alcohols. Next reaction using thionyl chloride. What is thionyl chloride? COCl2. Thionyl chloride is COCl2. So when alcohol reacts with CH3CH2OH, when alcohol reacts with thionyl chloride SOCl2, what do we get here? CH3CH2Cl, CH3CH2Cl, and this SO and O, we get SO2. SO2 is gas escapes out, and leftover chlorine and chlorine reacts with the hydrogen here. Therefore, we get hydrogen chloride. Hydrogen chloride also escapes as gas. Now, in this reaction, the byproducts SO2 and HCl, being gases, they escape out. So, what is the product here? This is only the product. When the product is only one, there is no separation needed. No separation is needed. Therefore, we get the product directly. Therefore, this is the best method for preparing the haloalkanes by using thionyl chloride. Right? And this process is known as Darjan's procedure. So the preparation of chloroalkane Preparation of ethyl chloride or chloroethane by using thionyl chloride is referred as a Darjan's procedure. These methods, the above methods means preparation of the above methods are not useful to prepare aryl halides. How do you get aryl halide? Aryl halide must get from phenol. So the reaction is nothing but a conversion of alcoholic group, that is OH group, into halo group. So here this is OH. So I shall write a bigger one. So here this is OH. Lone pairs are here. So in phenol, one of the lone pair shifts here, and of course this bond shifts here. Therefore, the bond shifting takes place in this manner. Therefore, what do we get here? This is a double bond OH plus, this is minus. So what happens? The COH bond, the bond between carbon and oxygen, acts as a partially double bond. Right, now this negative charge shifts here and this double bond shifts here in this manner. Therefore, we get minus here and OH plus. And again, this charge shifts here. Therefore, this charge shifts here. Therefore, what do we get here? This is in this manner minus. This is plus. Right, now finally this bond shifts here, this shifts to this. Therefore, what do we get? In this manner. So in phenol, what happens is OH group involves in resonance with the ring structure. The reaction, the OH group, the hydroxy group is not replaced by halogen atom. That's why by using this halogen acids, we cannot get aryl halides from phenols. Now, let us see the second method of preparation from hydrocarbons. Hydrocarbons means maybe alkanes or alkenes. Right. Now this reaction we are studying right from the lower classes. This is methane plus Cl2 in the presence of sunlight. Hydrogen chloride is removed here, therefore we get CH3Cl, chloromethane. This reaction does not stop. The reaction does not stop at monohalogenation. Therefore, what happens? Chlorine, in the presence of chlorine again H nu minus HCl, and one more hydrogen is removed. This is known as methylene chloride. Methylene chloride or dichloromethane. Right. Now one more hydrogen is removed. That means the reaction goes on until all the hydrogen atoms are removed or substituted. Therefore, Cl2 H nu minus HCl. What do we get here? This is CHCl3. Chloroform. This is chloroform CHCl3 or trichloromethane. Now again another chlorine molecule H nu minus HCl. Therefore, here we get CCl4 carbon tetrachloride. So this is one more method of preparation of haloalkanes. But only the thing here is we do not get mono substituted. We get the mixture of haloalkanes, that is dihalo, trihalo, tetrahalo, etc. Therefore, the separation is very difficult. Therefore, this is not suitable for the preparation of mono substituted alkanes. Now let us see one more reaction. This is CH3, CH2, CH3 in the presence of chlorine and sunlight. Now what happens? There are different possibilities for this reaction. So here the displacement of hydrogen may take place from the first carbon. Therefore, this is CH3, CH2, CH2Cl. This is 1 chloro, 1 chloropropane, 1 chloropropane. This is the yield is 45%. The yield is 45%. Plus, now the hydrogen from the second carbon atom also may be replaced. Therefore, we get CH3, CH, Cl, CH3. So, what is the name of this substance? This is 2-chloropropane. 2-chloropropane. What is the yield? 55%. Therefore, the 2-chloropropane is the major substance. Major substance. So, this is a halogenation of hydrocarbons, that is saturated hydrocarbons. Right. Now, here from alkenes, what is alkene? Alkene means the hydrocarbon has a double bond. This is alkene, right? So if you keep hydrogens here, what is this substance? Ethene or ethylene. Now this is a CH2, double bond CH2. Bromine is added in the presence of CCl4. So what we have to do here, CCl4 is a liquid, carbon tetrachloride. Initially the bromine is dissolved in the carbon tetrachloride. CCl4 is a colorless liquid, colorless organic liquid. When reddish brown bromine is dissolved in it, the CCl4 becomes a reddish brown. When ethylene gas is passed through this CCl4 in which bromine is dissolved, therefore what do we get? We get CH3, CH2Br. When bromine is taken by ethylene, the carbon tetrachloride loses its reddish brown color. Therefore, this is used as a distinguishing test of alkenes, that is unsaturated hydrocarbons from saturated hydrocarbons. Therefore, this is a test for unsaturation. Decolorization of bromine is test for unsaturation. How do we carry out this test? Initially, bromine is dissolved in CCl4, then unsaturated hydrocarbon is passed through it. If the reddish brown color is decolorized, it means lost, reddish brown color is lost. Therefore, it is understood that the hydrocarbon passed through CCl4 is unsaturated hydrocarbon. Now here, this is CH2, double bond CH2. This is CH3, CH double bond CH2. See, with respect to double bond, the alkyl chains are same. Therefore, we call it as a symmetrical alkene. Whereas with respect to double bond, here this is the alkyl chain has 2 carbon atoms, whereas here alkyl chain has 1 carbon atom on the right side. Therefore, this is referred as unsymmetrical alkene. To this unsymmetrical alkene, when halogen atom is added to unsymmetrical alkene, when halogen acid means maybe HCl, HBr, HI. Halogen acid is added to unsymmetrical alkene. Then what happens? See here, this is CH3, CH2, this is CH double bond CH2 plus HBr. Then what happens here in this HBr, H plus and Br minus. This is negative part. This is a positive end. This is negative end and this is positive end. So the negative part of the addendum is the molecule which is added to the double bond. The negative part of the addendum. What is the negative part of the addendum? Br minus. The negative part of the addendum is added to, is attached to, is bonded to the carbon with less number of hydrogen atoms. The carbon with less number of hydrogen atoms. In the double bond, what is the carbon with less number of hydrogen atoms? This one. So to this bromine atom, bromine is added. Therefore, this becomes CH3, CHBr, CH3. What is this substance? This is bromopropane, 2-bromopropane. Now, is it only the product formed here, 2-bromopropane? No. Another product is also formed, that is plus CH3. There is a chance of attacking this bromine, that is negative part to this first carbon also. CH3, CH2, CH2Br. This is 1-bromopropane. 1-bromopropane. Then what is the difference? This 2-bromopropane is 80% yield. That means the major product is 2-bromopropane and minor product is that is 20%, that is 1-bromopropane. Therefore, in this reaction, we considered that the product formed here is 2-bromopropane because it is the major product. Now, let us review this. When halogen atom is added to the unsaturated unsymmetrical alkene, then negative part of the addendum is bonded to carbon bearing less number of hydrogen atoms. So this particular rule is referred as a Markovnikov's rule. Markovnikov. This is Markovnikov's rule. So Markovnikov's rule states that when hydrogen bromide or halogen acid is added to an unsymmetrical alkene, then negative part of the addendum is bonded with carbon bearing less number of hydrogen atoms, that is Markovnikov's rule. Therefore, here the major product is as a negative part, that is bromine atom is added to the carbon with less number of carbon atoms, means middle carbon. Therefore, we get 2-bromopropane as a major product, that is 80%, and 1-bromopropane is a minor product, that is 20%. Right. So this is addition of halogen acid to alkenes. Okay, now can't we reverse this reaction? That means instead of getting the 2-bromopropane as a major product, can we get the 1-bromopropane as a major product? Is there any such reaction? Yes, definitely. So as we discussed the Markovnikov's rule, there is another rule, that is anti-Markovnikov's rule. Anti-Markovnikov's rule. Now what happened here? Same, that is let us take the CH3 CH double bond CH2 plus HBr. This in the presence of a peroxide like barium peroxide, Ba2O2. Peroxide means an oxide having more amount of oxygen than required for the saturation of the atom, saturation of the metal or other atom. That is peroxide, Ba2O2 is the peroxide. So in the presence of peroxide, the addition takes place in this manner, that is CH3CH. Hydrogen is added to the carbon bearing less number of hydrogen atoms, and bromine, that is the negative part of the addendum, is added to carbon bearing more number of hydrogen atoms. So This is anti-Markovnikov's rule. So anti-Markovnikov's rule states that in the presence of a peroxide, when hydrogen acid, HX means hydrogen acid is added to an unsymmetrical alkene, then negative part of the addendum is added to or bonded to the carbon bearing more number of hydrogen atoms. Therefore this is referred as a anti-Markovnikov's rule, or it is also referred as peroxide effect or Karash effect, K-A-R-A-S-C-H, Karash effect, because a scientist known as Karash explored this. Therefore this is a Karash effect or peroxide effect, because in the presence of peroxide the reaction takes place opposite to Markovnikov's rule. Therefore it is also referred as anti-Markovnikov's rule. So this is the addition of hydrogen acids to unsaturated alkanes to prepare the haloalkanes. Okay, now halogen exchange. Halogen exchange means already one halogen is there. This halogen is replaced by suppose it is Ri, right? This is replaced by HX in the presence of sodium iodide and acetone. We get Rx. So this is a halogen exchange. So here in this, of course, this reaction, let us write this as Rx plus Hi in the presence of NaI, acetone, we get Ri. For example, CH3Br plus hydrogen iodide in the presence of sodium iodide and acetone, we get CH3I, and of course here HBr. In the same manner, CH3Cl plus Hi gives NaI in the presence of acetone. What is the formula of acetone? CH3C double bond OCH3. This is a reaction medium. Acetone is a reaction medium. Previously we carried out the addition of bromine in the presence of carbon tetrachloride. Carbon tetrachloride is the reaction medium, because both bromine as well as ethylene, both are gases. In gaseous state the reaction does not take place, therefore there must be a reaction medium. That means some other substance is required to carry out the reaction. Therefore here this is reaction medium. What do we get here? CH3I plus HCl. So this halogen exchange takes place when alkyl halides are reacted with sodium iodide, hydrogen iodide. In the presence of sodium iodide and acetone, we get methyl iodoalkane. This reaction is known as Finkelstein reaction. Finkelstein reaction. Remember, keep this point in mind as we are discussing all these reactions. Each and every reaction is useful in conversions, organic conversions. Organic conversions. Now the next reaction is next reaction. So in this what happens? CH4. Suppose if we use fluorine. If we use fluorine, we get HF plus carbon. We do not get a fluoroalkane. We do not get fluoroalkane because fluorine has high affinity towards hydrogen than carbon. So we do not get a fluoromethane. We get a hydrogen fluoride. So fluorine has high affinity towards hydrogen. Therefore, because of this, fluoroalkanes are not prepared. Therefore, fluoroalkanes can be prepared in some other reaction, that is Schwarz reaction. Schwarz reaction. What is a Schwarz reaction? Chloro or bromo alkanes, that is alkyl halides. Alkyl halides are treated with silver fluoride or mercurous fluoride, CO, cobalt fluoride or antimony fluoride, etc. Then we get when alkyl halides are treated with silver fluoride, mercurous fluoride, cobalt fluoride, antimony fluoride, etc. We get fluoroalkanes. So here this is CH3Cl plus AgF. What do we get? AgF. We get CH3 fluoromethane plus silver chloride. Similarly, if we react CH3CH2Cl plus mercurous fluoride Hg2F2, what do we get here? We get CH3CH2F, 2 molecules here plus Hg2Cl2. So this is a Schwarz reaction. So in Schwarz reaction, haloalkanes are treated with fluorine compounds like silver fluoride, mercurous fluoride, cobalt fluoride, stibnum chloride, that is antimony fluoride, etc. Then we get have fluoroalkanes, and of course respective byproduct is formed. So these are the reactions in which haloalkanes are obtained by halogen replacement. Now, preparation of haloarenes. Haloarenes means benzene ring. On benzene ring, chlorine, bromine or iodine are present. Therefore, they are referred as haloarenes. Right. Here, this is, what is this substance? Toluene. This substance is toluene or methyl benzene. So this in the presence of chlorine, Cl2, in the presence of iron and of course dark. What do we get here? This is CH3Cl. What is this substance? 2-methyl chlorobenzene. 2-methyl chlorobenzene. Right. And of course, byproduct formed here is HCl. Okay. Now let us see. This is aniline. Aniline means C6H5NH2. Aniline. Aniline is treated with NaNO2. NaNO2. NaNO2 plus HCl, and of course at the temperature 273 degrees centigrade. What do we get here? N2Cl. N2 plus Cl minus. What is this substance? Benzene disonium chloride. Benzene disonium chloride. Okay. Now this is treated with Cu2x2. That is a cuprous halide. This cuprous halide, suppose if you take Cu2Cl2 in the presence of HCl, what do we get? We get here chlorobenzene. Chlorobenzene plus nitrogen is removed. If this substance is treated with Cu2Br2 in the presence of HBr, what do we get here? We get here bromobenzene plus N2 plus HCl. So this particular reaction, it is referred as Sandmeyer reaction. This reaction is referred as Sandmeyer reaction. Right. Now, these halobenzenes, aryl halides can be obtained by using a different reagent also. That means benzene disonium chloride, this is N2Cl, in the presence of copper powder and hydrogen acid. Copper powder and hydrogen acid. See here, only the reagent changes. Here we are taking the cuprous chloride and HCl. Here we are taking only copper powder and HCl. Therefore we get, what do we get here? Chlorobenzene plus N2. Similarly, in the presence of Cu plus HBr, what do we get here? This we get bromine plus nitrogen plus HCl. So this particular reaction, here it is a Sandmeyer reaction, whereas this reaction is known as Gattermann reaction. So all these named reactions I discussed in my previous video under the name named reactions. So please revise, write, practice all these reactions. Therefore, organic chemistry becomes very easy. So this is the preparation of aryl halides. Now, iodoalkanes, for the preparation of iodoalkanes. This is benzene disonium chloride, N2Cl plus Ki. Here iodine is not necessary, just like in Gattermann-Koch reaction in for the preparation of chlorobenzene and bromobenzene. Here in chlorobenzene we use copper and HCl, so here iodine is not necessary. Therefore we get here iodine plus N2 plus KCl. This is iodobenzene. Now, in the textbook, let us do one problem, that is This is benzene ring. H. Now HBr is added. What is the product here? See, in this product, here it is not mentioned peroxide. Peroxide is not mentioned on the arrow mark. As peroxide is not mentioned on the arrow mark, it is understood that we have to follow the Markovnikov's rule. Here this is the double bond. This is the carbon bearing more number of hydrogen atoms, and this is the carbon bearing less number of hydrogen atoms. Only one hydrogen is there. Therefore, Markovnikov's rule follows. Markovnikov's rule follows. Therefore, what do we get here? This is C, hydrogen, bromine, and of course here this is, so each one, this is hydrogen, this is right. So as Markovnikov's rule is followed, the negative part of the addendum, that is bromine atom, is added to the carbon bearing the less number of hydrogen atoms. Now let us see one more question of this type. Here it is, benzene ring, CH2C, CH double bond CH3, CH2. So here HBr, and of course here it is mentioned peroxide. As peroxide is mentioned, it is understood that anti-Markovnikov's rule should be followed here. Anti-Markovnikov's rule means negative part of the addendum should be is bonded with the carbon bearing more number of hydrogen atoms. That means this carbon. Therefore, what is the product here? The product here, it is CH2, CHH, CH2Br. This is single bond, right? So what is the name of this substance? 3-phenyl 1-bromopropane. 3-phenyl 1-bromopropane. Right, like this, what happens? You complete the exercise given at the end of the textbook, end of the lesson, and of course in text questions. Practice thoroughly. If you practice thoroughly, what happens? Your subject becomes strong. Therefore, you will be ready for facing the board examination. Okay, in today's class, let us conclude here, and in the next class, let us start the properties of haloalkanes and haloarenes. If you have any doubts, you can give in the chat box, or you can send those doubts to my WhatsApp number. So I shall discuss whatever the doubts you have in the next class, or in the WhatsApp I shall clear those doubts, and of course send to your personal numbers. Thank you very much for attending the class. No, we have attended.